Yeah, we're doing natural log integration today. So first off, we're going to let u be a differentiable function of x. We'll need that in a second. All right, so if we have the integral of 1 over x dx, this integrates to the ln of x, the ln of the absolute value of x plus c. Okay. If I have the ln of u du, that would be, well, the ln, the absolute value of u plus c. Okay. All right. Next up, if we're going to integrate, so I'm going to take a look at this and be like, I'm going to rewrite my integral as 2 times 1 over x dx. And I remember that the integral of 1 over x dx is ln. So this is the ln of the absolute value of x plus c. All right, next. Now I have the integral of 1 over the quantity 4 minus 1 dx. And I cannot integrate that. So if I rewrite this, it's going to look like 4x minus 1 to the negative 1 dx, and I just don't know what to do with that. So I'm going to have to, well, I don't know what to do with that because of the negative 1. Wow, I just erased that. Okay, that's okay. We're going to erase it anyway. So I'm going to take the bottom part and set that equal to u. Because I remember that if I have something that looks like 1 over u, I can take the integral of that. So let's see what happens when I take the derivative, since I need to change my dx to du. So du is equal to 4 dx, okay? And then dx is equal to du over 4. All right, so let's see. My dx is being replaced with du over 4. So that is the 1/4. I can bring out the 4 to the front, times the integral of 1 over u du. Then I get 1/4 times the ln of the absolute value of u plus c. Replace out the u, x ln of the absolute value of x minus 1. The only time I can drop the absolute value signs is if I know that my input is always going to be positive, and because x is, we don't know if, oh, I forgot a 4x. 4x minus 1 is not always positive. It's a line, you know. Sometimes it's positive, sometimes it's negative. So we cannot drop the absolute value signs. Okay. Let's find number 3. Okay, so this time, this one looks tricky. Okay, so I'm going to make the inside part of the denominator equal to u. So x plus 1, because then I get u squared on the bottom. Let's see what happens. Okay, so I get 2x over u squared, and then we're going to replace dx. So du is equal to dx. So just du replaces dx. And then I notice there's still an x left. So let's go ahead and isolate x. I get u minus 1. So I now have 2 times u minus 1 over u squared is equal times du. Look, monomial in the denominator. I'm going to distribute 2u minus 2 over u squared du. Then divide in the monomial. So I get 2u to the negative 1 minus 2u to the negative 2 du. And this looks like 2 over u du minus the integral of 2u to the negative 2 du. Okay, so anytime your integral has a negative 1, power to the negative 1, you're going to end up with an ln, probably, most likely. Okay, so we want to make sure that we change the integral to look something like, 1 over u, 1 over x. Okay, so the 2 can come out to the front. 1 over u du minus 2 times u to the negative 2 du. This is an unnecessary step, but I like it. So I get 2 ln of the absolute value of u minus 2, and then this is just power rule, u to the negative 1, reduce the power by 1, divide by the new power, okay, plus c. And then we're going to substitute out u, if you forgot what u was, like I did. U is x plus 1. So I have 2 times the ln of the absolute value of x plus 1. And then the negative times the negative is a positive. So 2 over x plus 1 plus c. And we're done with that one. Okay, let's do another one. All right, so we have definite integral this time. So the integral from 2 to e of 1 over x times ln x dx. And I am going to, I can see that there's like this 1 over x part. And I also know that the derivative of ln x is 1 over x. So I'm thinking that there might be some like special cancel-y stuff if I make u equal to the ln of x. Okay, so I get du is equal to 1 over x dx. So dx is equal to, so times x gives me x du. Okay, so we have the integral from 2 to e of 1 over x times u times x du. Like I said, some cancel-y stuff. All right, so I have the integral from 2 to e of 1 over u du. I forgot. I messed this up. Whoopsies. I forgot to change my bounds. All right, let's change some bounds. So we get u of the lower bound, which is 2, okay, of ln of 2. So the lower bound is going to be between ln of 2. And the upper bound, u of e, is ln of e, which is 1. Remember? Yeah. Okay. Remember when the base and the number match, you get 1. So the ln of 2 to 1. All righty, here we go. We're going to take the integral. I get the ln of the absolute value of u evaluated from ln 2 to 1. Time for some substitution. Get the ln, the absolute value of the ln of 2. Oh, I messed that up. Wow. Get your head in the game here. Okay, we're going to do the ln of the upper bound, which is ln of absolute value of 1, minus the ln of the natural log of 2. Yeah. Okay, we can drop the absolute value signs because 1 is positive, and then also ln 2 is positive. So this can change to a parentheses instead of an absolute value. And the ln of 1, trying to finish this video before class. Okay, the ln of 1 is 0 because e to the what power gives me 1. That's going to be a 0. So my answer is just negative ln of the ln of 2. All right, that's it. Okay, what is next? Oh, done with that video. Excellent. See you later.